Hello students. Previously we have done different activities for concluding the centrifugal force and gravitational force of the earth. And what did you conclude after these activities? We have concluded that due to its rotation, earth gets a power or force. This force works away from the earth's center is called centrifugal force. And due to this centrifugal force, any object on the surface of the earth would be thrown into the space. However, the gravitational force working towards the earth's center at the same time, and this force is a many times greater than centrifugal force. Hence, any object on the surface of the earth remains at the place where it exists. These centrifugal force and gravitational force are responsible for the occurrence of tides. Along with these factors, the gravitational pull of the sun, the earth and the moon also affected on the occurrence of tides. Previously, we have learned that the level of seawater changes after a specific period of time. After every 12 hours, 25 minutes, a cycle of high tide and low tide gets completed. And we have learned that the timing of the tide varies every day. The range of tide also keeps on changing. Today, we are going to learn the types of tides. Let us see.
And now let us see types of tides. As the timing of the tide varies every day, we have learned this part previously, the range of a tide also keeps on changing. Generally, the highest high tide occurs on full moon day. Look at this bulge of oceanic water on full moon day. Generally, the highest high tide occurs on full moon day and new moon day. Whereas on the days of the first and the third quarter, the high tide is at its minimum. Spring tide and neap tide are the two types of tides.
Students, previously we have learned that every lunar day coastal areas experience two high tides and two low tides every 24 hours and 50 minutes. High tides occur 12 hours and 25 minutes apart. It takes 6 hours, 12 minutes and 30 seconds for the water at the shore to go from high to low or from low to high. This is a daily movement of seawater. We experience two high tides and two low tides during 24 hours and 50 minutes. This is the daily movements of seawater. But during lunar month, we experiencing higher high tides and lower low tides, as well lower high tides and higher low tides. What is a lunar month? A lunar month is a complete cycle of phases of the moon as seen from the earth averages 29 days, 12 hours, 44 minutes, 3 seconds solar days. And during one lunar month, we experiencing two higher high tides and two lower low tides, as well two lower high tides and two higher low tides. And now look at this figure number 3.7. it is about spring tide. On new moon and full moon days, that means twice during one lunar month, the gravitational pull of the sun and the moon act in the same direction. Due to this, the total pull increases. Hence, the tide on these days, that means on new moon and full moon days, is much higher than the average high tide. And this is known as a spring tide. As the bulge at the high tide is greater, the water at low tide recedes much more. Look at this. The water at low tide recedes much more. The water level during spring tide is higher than the average high tides and lower than the average low. For measuring the water level, look at this image of the tide gauge. The tide gauge is a measuring level of water. Thus, during every lunar month, on a new moon and a full moon days, the sun, the moon and the earth falls in one line. A place on the surface of the earth located at the opposite side of the moon will experiencing higher high tide than the average high tide. And at the same time, a place on the surface of the earth which is located at an antipodal location of a place which having higher high tide also experiencing higher high tide at the same time. And at the same time, the places that are at right angles to those having higher high tides will experiencing lower low tide. That means lower than the average low. And now look at this figure number 3.8. It is about neap tide. While revolving around the earth, the moon makes a right angle with respect to the earth and the sun twice during one lunar month. This position occurs on the first and the third or last quarter of each month. On both these days, the forces of both the sun and the moon operate at right angles on the earth. At the places where the sun causes high tides, the gravitational pull of the moon, which is at right angles, also acts on the seawater. Due to such a conditions, the water level rise is less than usual at the time of high tide. Similarly, fall in water level is less than usual at the time of low tide. This is because the attraction of the sun and the moon are not complementary but at right angles to each other. Such tides are called neap tides. Neap tides are a little lower than the average high tides and a little higher than the average low tides. Thus, on the first and the third or last quarter of each lunar month, when the sun and the moon are at right angles to each other during waxing or waning moon, a place that experiencing this position of these celestial bodies will experiencing lower high tide is called neap tide. and at the same time a place which is at an antipodal location of a place which experiencing lower high tide also experiencing lower high tide, and the places that are right angles to those having lower high tide will experience higher low tide at the same time. Tides are movements of seawater occurring daily and regularly. The tides are continuously occurring natural phenomena. After reaching the maximum water level during high tide, the low tide sets in. Similarly, after reaching the lowest water level during low tide, the high tide sets in. The level of seawater changes after a specific period of time. After every 12 hours and 25 minutes, a cycle of high tide and low tide gets completed. We have seen previously this part. Now we are going to learn timing of the tides changing daily. How? We will see. And now look at this figure number 3.9. Why do the tide timings change daily? There will be high tide at point P as it is opposite to the moon. Point P located exactly opposite side to the moon. As a point F is opposite or at an antipodal location to the point P, it will also experience high tide at the same time. If there is a high tide at point P at 7 am, at the same time point F, which is located at an antipodal location to the point P, will also experience high tide at 7 am. And as we know that Earth rotates eastward, that means from west to east, on its tilted axis, and to complete one rotation, Earth takes 24 hours. That means it will take 24 hours for point P to come back its original position. If point P faces to the moon and experience high tide at 7 am, at the same time point F, which is located at an antipodal location to point P, will experience high tide at 7 am. And due to Earth's rotation on its tilted axis, point P will be at point F after 12 hours. That means at 7 pm, point P will be at point F. The same change will be also occur with reference to the point F. After 12 hours, point F will be at point P at 7 pm. But at this time, that means at 7 pm, point F will not experience the same high tide, because in the meanwhile, the moon also would have moved a little ahead, approximately 6 degree 15 minutes. As we know that there are 60 minutes in each degree. Hence, it will take 25 minutes more for the point F to the position opposite to the moon. That means after 25 minutes from 7 pm, when point F will face to the moon, will experience high tide at 7 past 25 minutes pm. And At the same time, that means at 7 past 25 minutes PM, point F experience high tide. At the same time, point P, which is located at antipodal location to point F, will also experience high tide at 7 past 25 minutes PM. Later again, after 12 hours and 25 minutes, point P will face to the moon. Look at this point, labeled as a point P1, will experience high tide at next day's 7 past 50 minutes AM. And at the same time, point F1, which is located at an antipodal location to point P1, will experience high tide at next day's 7 past 50 minutes AM. Note that, like Earth, Moon also rotates on its axis and revolves around the Earth on its elliptical orbit. And to complete one rotation on its tilted axis and to complete one revolution around the Earth, Moon takes same timing, that is 29 days, 12 hours and 44 minutes, 3 seconds, solar days. And this is one of reason that the tide timings change daily. And thus we have noted that the difference between two high tides is 12 hours 25 minutes. And now we will learn about waves. And now we are going to try one activity related to occurrence of water waves. Take a wide open large dish. Look at this dish. Keep the dish on a table or a flat surface. I have kept this dish on the surface of the table. Fill water in the dish up to the rim. Look at this water I am going to fill in the open large dish. I have filled water into the dish up to the rim. Look at this. And now we have to generate waves in the dish. Is it possible to generate waves without touching or shoving the dish? We will try to doing so. Now I am blowing air with my mouth on the water. You can see waves on the surface of water filled in the dish. Thus, we have noted that by blowing air with our mouth on the surface of water, waves can be generated. In what different ways can you generate waves in the dish? Just now, we have observed that by blowing air with our mouth, waves can be generated in the dish. Now look at this stone piece. I am going to drop this stone piece in the dish. We will observe what will happen. You can see waves can be generated after dropping the stone piece in the dish. Look at this, how waves generates. Once again see, after dropping a stone piece in the dish, waves can be generated. Look at these waves. So we have noted that by dropping an object like a stone piece in the dish, waves can be generated. Now let us see geographical explanation of our activity just now completed. And now look at this, a cup of tea. If you blow air over a hot milk or tea while drinking, ripples are generated on the milk or on the tea. You can see after blowing air with mouth how ripples takes place on the tea. In the same way, because of the force of the wind, water appears to be moving. The seawater gets pushed by the wind and ripples are generated on the water surface. These are called waves.
The seawater moves up and down or slightly forward and backward due to the waves.
And now look at this figure number 3.10, waves coming to the coast. The waves bring the energy contained in them to the coast. They break in the shallow waters near the coast. Large or small waves are formed continuously at the surface of the sea. Generation of waves is a natural and a regularly occurring phenomenon too. And now look at this figure number 3.11, the structure of a wave. The seawater gets pushed up and down because of the wind. The raised up portion of a wave is called crest and the depressed one is called trough. If a strong wind is blowing in one direction, large waves are generated. The vertical distance between a crest and following the trough is called the amplitude of the wave. Amplitude means the height of the wave. Whereas the distance between two successive crests or two successive troughs is called wavelength. Look at this, distance between two successive crests is called wavelength, as well the distance between two successive troughs is called wavelength. The wavelength, its amplitude and its velocity means speed of wave depend on the velocity of wind. What is the velocity of waves? If we stand at the coast, we feel the waves are coming towards the coast. If a floating object is thrown at a distance in the sea, we find the object moving up and down at the same place. It does not come to the coast. It means the water forming the wave also does not come to the coast. Remember that the water in the wave does not move. What moves is the energy.
And now look at this geographical tool, an anemometer, made by John Thomas Ramey Robinson. An anemometer is an instrument that measures wind speed, wind pressure, as well wind direction. The main reason of a wave generation is the wind. But at times, due to earthquakes or volcanic eruptions occurring below the floor of the sea, waves get generated. Such waves assume a great height in the shallow waters near the coast. These waves are very destructive. They cause huge loss of property and lives. These waves are called tsunamis. In 2004, tsunami waves were generated because of the earthquake that took place near Sumatra Island of Indonesia. They devastated the east coast of India as well of Sri Lanka.
And now look at this figure number 3.12, beach. The waves cause erosion along the headlands and create beaches in the protected locations in the bays.